Inverse functions. The objective of this video is to apply the horizontal line test to determine inverse functions. So an inverse function exists if and only if one relation contains yx when the other relation contains xy. So basically we take our xy values and we flip them. That will be the inverse of a function. We use a notation -1, which is read f inverse, to denote an inverse of a specific function. So there are various ways to determine if something has an inverse or to find the inverse. If we have the graph of two functions, we can actually use something similar to the vertical line test, which is called the horizontal line test, to determine if a function has an inverse. If it passes the test, then it is said to be a one-to-one function, meaning there is solely one x that goes to one y. That way, it could be flipped. So in my first image, f of x, it passes the horizontal line test. So it is a one-to-one function, meaning that f of x here has a function. Has an inverse. In my second image, this function would have too many x values that correspond to y. Therefore, it fails the horizontal line test and does not have a function, does not have an inverse. It is important to know whether something has an inverse or not, because if you are asked to find the inverse of a function, if it does not have an inverse, you do not want to waste your time. In this exercise, you would need to use a graphing calculator of some sort and apply the horizontal line test to determine whether its inverse function exists. You just need to determine a yes or a no. For my first equation, I end up with this absolute value image. And if I were to pass a horizontal line through this, there will be too many x values corresponding to the y, so it fails to have So in this case, it fails. So the first one is no. For the second image, my cubic function, it passes the horizontal line test. Therefore, yes, it has an inverse. C, a reciprocal function, would also pass So yes, has an inverse. And the last one, a parabola, fails because at a horizontal line, too many x values for any given y, not one-to-one. So no.